Vertical asymptote at x equals 2. How do we find our horizontal asymptotes? What do I do for my horizontal asymptotes? The limits at infinity, you got it. So here I'm going to be doing the limit as x approaches infinity of 3x squared over x plus 2 squared. I take the big stuff, so the 3x squared, and then the x squared on the bottom. So here I have the limit as x approaches infinity of 3x squared over x squared, which will give me a 3. And negative infinity, I'm going to get the same thing. So y is equal to 3 as x goes to plus or minus infinity. And in this one, I am going to want to find the x and y intercepts. So I'm going to do this as kind of a B star right here. Where we find the x-intercept and the y-intercept. So for the x-intercept, that's when y is equal to 0. So here I'll have 3x squared over x plus 2 squared equals 0. So I get 3x squared equals 0, which just gives me x equals 0. And then my y-intercept will happen when x equals 0. So that is 3 times 0 over 0 plus 2 squared is equal to 0, which gives me the same thing. So the x and y-intercept are actually the same value, and there's only one x-intercept this time. Okay, so then for C, we're setting up our interval using our critical values. So I'm looking at f prime is equal to 0, which is like taking the numerator of f prime and setting it equal to 0. So that would give me x equals 0. And then f prime does not exist is like setting the denominator equal to 0. So that's x plus 2 equals 0, which gives me negative 2. And what do I already know about negative 2? It's a vertical asymptote, you got it. So that's definitely not going to be a max or a min, but it is going to go in my table of values. So now we make our table of values using f prime. So here I'm going to have my interval, and I'm going to separate at negative 2 and 0. And I want to pick a test value on each interval that I then plug in to f prime so that I can make conclusions about f. But I'm just going to immediately write here that negative 2 is a vertical asymptote, so I don't accidentally think later that it's a min or a max. Okay, so now I am doing f prime of negative 3. And here I get a negative over a negative, which gives me a positive. And then I'm doing f prime of negative 1. which gives me a negative over a positive, which is negative. And then I'll do f prime of 1. Oops. Which gives me a positive over a positive, which is positive. So here I'm increasing, and then I'm decreasing, and then I'm increasing. Do I have a maximum at x equals negative 2? No, you got it. That's my vertical asymptote. We can't have a max or a min at a vertical asymptote. So my conclusion for C here is that it is increasing on negative infinity, negative 2, union 0, infinity, and decreasing on negative 2, 0. Then for part D, what do I have happening at 0? You got it. That goes from decreasing to increasing, so that's a min. So for D here, I have a local min at x equals 0, which I already plugged in. I know that's 0, 0. That's also my intercept. So my local min is at 0, 0. Okay, and so I'm just gonna finish the next two part where we do really quickly the second derivative, and then next class we'll put all the stuff together to graph it. So E, I repeat all of the same steps that I just did, but now I'm doing them with f double prime. So I want to know when f double prime equals to 0. So that's when my numerator equals to 0. So that's negative 24 times x minus 1 is equal to 0, which gives me x equals 1. And then I want to know when f double prime does not exist. And that's when my denominator equals to 0. So in this case, that's x equals negative 2, which we know to be our vertical asymptote. And if you'll bear with me, I think we're almost done. I think we got about 2 minutes of talking left. So that's my vertical asymptote. And now I redo the same chart that I just did. It's just that I'm going to plug into f double prime and use my pips. These are what's called pips instead of f prime. So I'm negative infinity to negative 2, negative 2 to 1, and 1 to infinity. I have some test values. I have f double prime, and then I have f. And that negative 2 is a vertical asymptote. It cannot be an inflection point. So I plug these into f double prime. So I get positive, positive, negative. Happy, happy, sad. And so we can make conclusions about concavity here. Do I have any inflection points? 1, you got it. It changes concavity there, so that's my inflection point. So we need to plug that into the original function. So here I can say that I have an inflection point at x equals 1. So we plug in f of 1 to the original function. So I'm like 3 times 1 squared over 1 plus 2 squared is 3 over 9 is 1 over 3. So my inflection point is 1/3. And that is where we're going to end today. Next class, we'll put all of this information together and graph it. If you guys want to look at it and try to draw a graph over the weekend, that would be awesome. And then you'll kind of see like where you have questions, where you're stuck, where you're not like getting it. Next class will also be entirely curve sketching. I'm hoping to have time to sketch 2 full curves next class since we won't have to start off with anything else. Are there any questions?